Okay, so we have a question here from the M1 textbook. Question number 16 from chapter review 2, page 37. And we're here asked to answer this question about two cars A and B moving in the same direction along a straight horizontal road. At time t equals 0, they are side by side, passing a point O on the road. Okay, car A travels at a constant speed of 30 meters per second and car B passes O with a speed of 20 meters per second. Okay, so you got A and B, and they're all starting at the same point O. But the initial speed of A is 30 meters per second. The initial speed of B is 20 meters per second. Okay, car B passes over the speed of 20 meters per second and it has a constant acceleration. So the acceleration for B is 4 meters per second squared. The acceleration for A is 0 meters per second squared because it's saying that it's going at a constant speed. Okay, car A travels a constant speed. Okay, find the speed of B when it has traveled 78 meters from O. So let's say that's a distance of 78 meters. We want to find the speed of B. So the final velocity of B after 78 meters. So we're going to use SUVAT here. Okay, so we know S-U-V-A-T, the SUVAT equations we'll think about. So we're going to fill in all what we know. So we know that the distance is traveled is 78 meters. Its initial speed is 20 meters per second. Its final speed is what we have to find. The acceleration is 4 meters per second squared, and the time we don't know. However, I think that's enough for us. We see V, U, A, and S, V squared equals U squared plus 2AS. So V squared is equal to U squared, which is 20 squared, plus 2 times 4 times 78. Okay, so V is going to be the square root of all of that. So V is going to be the square root of 20 squared plus 2 times 4 times 78, which is 32 meters per second. Okay, so that's the answer to part A. Part B says the distance from O when B is 78 meters from O. The distance from O of A when B is 70 meters. Okay, the distance from O of A. Okay, so when B is 78 meters from O, you got to find the distance of A from O. Okay, so now what we need to do here is to see what's going to be common when B is 78 meters from O. At that same time, we want to find what distance A is from O. So the thing that links them together is their time. Okay, so let's see what the time is. How long does it take for B to reach 78 meters from O? Okay, so how long does it take? So again, if we look at what we've been given here, we're looking at the same situation. Okay, we want to find the time. We can use V equals U plus AT. Okay, so we know the final speed is 32 now. We know that that's 32. All right, so we found that now. This is now 32 meters per second equals 20 plus A, which is 4 times T. So you're going to have 32 minus 20, which is 12, equals 4T. So T is 3 seconds. Okay. Yeah, so now we know that it's 3 seconds, so therefore we want to find how far does A travel in 3 seconds. Well, for A it's not a big problem, it's just going at a constant speed. So we know that as it's going at a constant speed, the speed is equal to distance over time. Therefore the distance is equal to speed times time. This only works when it's constant speed. Okay, so the speed is how much? The speed is 30 meters per second times 3 seconds, so it's 90 meters. 90 meters. So we know that after 3 seconds is 90 meters away from O, so the distance from O of A when B is 78 meters from O is 90 meters. Then this is the time when B overtakes A. Okay, the time when B overtakes A. So look, you see B, after 3 seconds, B is 78 meters from O and A is 90 meters from O. Okay, so after 3 seconds, okay, one is 90 meters away and the other one is 78 meters away. So we got to find out what time they're going to actually be exactly the same distance from O, basically. The time when B overtakes A is going to be the time when they're both the same distance from A, because that's when they're overtaken. So they have covered the same distance. Okay, so for part C, the distances that they travel must be the same. So let's look at A and let's look at B. Okay, so let's look at Suvat here. And let's look at Suvat here and decide what to do. We want the distance to be both the same. So that's why I'm going to link them together with this time. The initial speed of A was 20 meters per second. We don't know what the speed is going to be at the time that they overtake. The acceleration is 4 meters per second squared, and we don't know the time. That's what we have to find. Okay, for B, the initial speed is 20 meters per second. It's 30 meters per second, and the final speed is also going to be 30 meters per second because it's going at constant speed. Acceleration is 0, and the time is what we have to find. So if we look at these two, what can we do here? We can say we want to have an expression for S. So I know that S equals ut plus a half at squared. I want to have an expression for S which has t in it as an unknown, so I can find what t is. And here, well, we know that speed equals distance equals the speed times the time, velocity times time. Okay, so for this one it's pretty simple. Okay, for this one you're going to have basically S equals 30t. And here you're going to have S equals, now U is 20, so 20t plus a half times acceleration, which is 4 times t squared. Now these have to be equal to each other. They will have, when B is being overtaken by A, they will have covered the same distance. So we can make these two equal to each other and we'll have an equation. So you say 20t plus a half times 4t squared is equal to 30t. So if we now solve this equation, we can just first of all cancel out that 20t plus a half times 4 is 2, plus 2t squared equals 30t. Bring everything to one side as is a quadratic, so 2t squared minus 10t equals 0. So you're going to have t squared minus 5t equals 0. So you have t and t minus 5 equals 0. Therefore t is equal to 0. Now that's obviously when they started off. Okay, and t is equal to 5. So of course our answer is 5 seconds. Okay, you can say A overtakes B after 5 seconds. And there we have the answer to that question.